Hi friends, I'm Austin Knight, and I lead a hydrogen business at Chevron, a company that provides energy to the world. I live here in Houston with my wife and 2 children, who are the same ages as many of you listening to this video. Energy is an important part of everyday life. Every time you play a video game, or use a cell phone, or drive in a car, you're using energy. Chevron delivers the energy people depend on every day. We're focused on protecting our environment and addressing climate change. We're actively working to lower the carbon intensity of our oil and gas business while also growing lower carbon businesses, such as a global hydrogen business. Did you know hydrogen is the most abundant element in the universe? More than 90% of the sun is hydrogen. Tiny hydrogen molecules contain huge amounts of energy that can be used as a lower carbon energy solution, which means less pollution in the world. At Chevron, we have many jobs like scientists, engineers, chemists, and geologists who work together to figure out how to deliver energy safely and reliably. We consider ourselves problem solvers, and we're constantly thinking of ways to deliver energy with fewer carbon emissions. To continue these efforts, we will need students like you to solve the problems of the future. So thank you for your participation today. I hope you enjoy the lesson.
Hi everybody, this is Jason, Manager of Science Outreach, and today I am the Chevron Maker Annex to show you how to build molecules. And I'm going to show you how to build some very particular molecules because our friends at Chevron are in charge of producing these types of molecules for use in your car. And I want to show you how they're made and how they're similar, how they're different, how they work, and some future fuels we might use using one of the molecules down the road a bit. So first of all, take a look. I have 2 different molecules here. I have an octane molecule and I have a methane molecule. Both of these molecules are different types of gas, and both of them can be used as fuel for different things. Now, you also know methane as a very, very funny thing. When animals produce gas of their own and release that gas as a fart, that right there is methane. So methane is a single carbon molecule, which is this black molecule right here, or a single carbon atom, and 4 hydrogen atoms or hydrogen molecules to make this molecule methane. So methane is used in some ways as an alternate fuel to power certain types of vehicles, but not too regularly right now. Now think about that. We have 1 carbon molecule right here making methane, and over here we have a molecule called octane. It has 8 carbon molecules and 18 hydrogen molecules or atoms. So let's think about that. There must be gases in between these 2. There are. If you have a 3 carbon hydrogen surrounding molecule, you have propane. Lots of you use propane inside your barbecue. If you have 7 carbons and about 14 hydrogens, you have septane. Now let me talk about septane and octane for a moment. Both of these molecules are created, if you will, or found or extracted when you crack open natural oil, which we find in the ground, which is basically dead stuff from millions and millions and millions of years ago. Being a chemist is doing the job of figuring out what different molecules do and how they change when reacting with other molecules. So basically, chemistry is the science of change. So this was really interesting. When they first thought, oh, maybe we can use these as fuel for our cars, they realized that septane, under any type of pressure whatsoever, will spontaneously combust. So if we use septane in our cars, our engines would blow up. That's no good. But then they realized if you have octane, just 1 more carbon molecule and 3 more hydrogen molecules, atoms, you will then be able to put that under pressure and use it in our vehicles. If you go to the gas station, you'll sometimes see 87 as your gas choice. That means this: it is 87% octane and 13% septane. meaning that at a certain point, that septane mixed with that octane will combust and help our engines run. And that is what chemists do. They figure these things out for us so that we can have cars that move and go hundreds of miles before we need to get gas again. It's pretty cool, huh? Now, I told you one of these molecules can be used as a fuel source down the road. That molecule or that atom is hydrogen. We're hoping to create hydrogen fuel cells that will allow hydrogen and oxygen to be fed into an anode and cathode and create electricity to power a car, and the byproduct will be water. But that's down the road. But what I want you to understand about this hydrogen atom, element, molecule is this. There is more hydrogen in our universe than any other element or atom all put together. Our universe is anywhere, depending on the scientist, anywhere between 70% and 75% hydrogen. The entire universe, 75%. If you look at these particular molecules that we have, methane and octane, you can see that over here, the methane is 80% hydrogen. And over here, the octane is 70% hydrogen. So it stands to reason that 70 to 75% of the known universe is hydrogen. 20 to 24% is actually helium. So hydrogen is a single proton with a single electron surrounding it. Helium is 2 protons, 2 neutrons, and 2 electrons going around it. Those 2 elements make up 90 up to 99% of the universe. And then in the rest of the periodic table, to 120 something, it is everything else, that 1%. So gold, silver, platinum, iron, magnesium, all of that makes up 1% of the entire universe. So we have so much hydrogen, and we have a lot of it here on the planet Earth, that it stands to reason that down the road, that will be a good alternate energy. Now, this is okay to do here at the museum. You can actually come here and make a methane molecule, you can make an octane molecule, you can make all kinds of different molecules. But at home, it might be difficult to find these different sort of balls and connectors. So here's a different way you can do it. Grab some paper, some glue, some coffee stirrers or toothpicks, and some multicolored marshmallows. You can take those marshmallows and you can make one color carbon, you can make one color hydrogen, and then you can go ahead and make, why is it sticking? You can go ahead and make your methane, just like that. So as you can see, the green marshmallows are the hydrogen atoms, elements, molecules, and the carbon right there is the single yellow one. And this makes that methane molecule. And then I also have the octane molecule over here. Make sure it doesn't stick. It's sticking a little bit, but let me get it up. It's gonna come, just give me a second. There we go. And here's your octane molecule with this time 8 yellow marshmallows, and you have 18 hydrogen molecules here. So as you can see, I kept it consistent. The green is hydrogen, the yellow is carbon, and you can make this as well. And you can find examples of all these different types of molecules on the interwebs. Okay, if you liked this video, please hit that subscribe button so that you can see all the videos we have to offer. If you want to come build molecules, the museum is open and we have that molecule station always ready to go, so come and build some. If you build some at home, take some pictures, take some video, go ahead and send it to our social media sites, tag us, and you'll be a big superstar. With that, I hope you're having a good day. I hope to see you soon at the museum. Bye for now.